Okay, this is part 2 of the Kyosho Inferno 10 electric conversion build series. I'm going to go over 3 parts here: the center differential, the shocks, and the universals and wheel hexes. Okay, so for the center diff, previously I tried to make this a sealed center diff so I could fill it with diff oil and make it tunable. Although that does work for the front and rear differentials, when I tried doing it on the center diff, I found quite a lot more leakage of oil compared to the very small amount I was getting on the front and rear diffs. And that's because of the interface here between the center diff housing and the spur gear. It's a different interface than what you have on the front and rear diffs. And this interface isn't a smooth interface. It has some sort of topography to it, and that makes it very difficult, or perhaps even impossible, to properly put a gasket around there so you could seal this interface here from diff oil leaking out. So what I decided to do instead is to lock the center diff, and there's a very simple way to do this, although I would point out the way not to do it is how I had seen it done with the one that actually came with this car when I got it. The previous owner basically tried to glue everything on the inside to force it to lock up. There's a much simpler way you can do this. And in the past I talked about using different kinds of O-rings for the front and rear gear diffs. So all you have to use here is, you can get it from any brand, but Axial makes a 5x1mm O-ring set. It's a 10-piece set. You take 4 of these and you put 2 on each side of these. For each of these input shafts, you put 2 of those O-rings in there, and what that'll do is it'll push those input shafts far enough toward the center so that there's enough bind so everything locks up. And this assembly will still tighten down so it doesn't push everything so far in that you can't actually close the assembly, because the O-rings themselves also have a little bit of flex, right? So you can close everything down and tighten all 4 screws here, and there's enough pressure when everything's closed for the amount of spacing that those O-rings provide to push everything in and lock it down. So this center diff now is completely locked and spins freely. It's perfectly fine. So that's what I'm going to use on this car. The only problem there is that without having an actual center diff and without having a slipper clutch, you have basically what's like a locked slipper. Okay, so as long as you don't apply too much power through the drivetrain, this should be okay. Now granted, this car doesn't have ball differentials. A ball differential would be much more, it would need a slipper clutch or at least a center diff of some sort, much more than gear diffs. So I think this will hold up okay, especially since I only plan to put maybe a 13.5 in this, maybe a 10.5. Should be fine. So that's the center diff. So oil-filled diffs front and rear, 5,000 weight oil presently, and then a locked center diff. For the shocks, I'm using standard bore Kyosho triple cap shocks. These are from the ZX5 or RB5 series. You could put big bores on here. I just happen to want to use these. And what I wanted to do is make sure that I can have the shock be long enough so that it can mount onto the arms at full droop and not have the shock be so short that it actually pulls the arm up and I don't get all the droop I was aiming for with a particular shock length. So all you really have to do is to use these shocks with the longest rod end at the bottom, and you'll actually make the length that you need for both the front and rear. The rear case is especially long because the shock is at such an angle, and the distance between the holes on the arm and the holes on the tower are really quite large. If this tower had more holes that spread out this way, then you can get away with using a shorter shock to make full droop. But then of course that changes the shock geometry. But in any case, this can work. And what I'm using presently for my initial setup are low-C green springs up front. That's a 3.5 weight pounds per inch spring, and associated white springs in the rear. That's a 2.1 pound per inch spring. So this is a little bit harder than their green spring, the associated green spring. And these are just springs I had lying around, so there's no particular reason why I went with associated rear springs and low-C front springs. It's just what I had, and I think it's in the window of what I would be looking for anyway. For the oil, I have 40 weight in the front and 35 weight in the rear, and I'm using the 2B pistons front and rear. So on these standard bore shocks, Kyosho have, I think, a 2A, a 2B, a 3A, and a 3B. So you have two sets of 2-hole pistons and two sets of 3-hole pistons. The 2B piston is basically like an old associated number 2 piston. The 2B is a 2 by 1.3 millimeter piston, and the associated number 2 is like a 2 by 1.36 millimeter piston, something like that. So it's pretty close. The 2A piston, I think, is a 2 by 1 millimeter piston, much smaller piston holes. And the 3A and 3B, I think, are like 3 by 1 and maybe 3 by 1.2 or something along those lines. So I'm gonna use the piston that is closest to what I'm familiar with on my older associated shocks. That's the 2B piston. Okay, and you take this, you do a drop test on the floor, and it packs nicely. It doesn't slap the ground or anything, so I'm quite satisfied with that. One trick that I played to get more droop on the front is to cut out the little ears at the bottom of the chassis here. So on the rear, you can see here you have these little ears that stick out. This is normally on a 1A scale chassis. You would have these and little droop screws on the inside of the suspension arm you could use to vary droop. Okay, so there are no droop screws on these Kyosho laser arms. These are really Kyosho laser arms. So really this ear just limits droop. But the rear droop is already plenty. I don't have an issue with that. But at the front, those ears were making these arms not quite flat, but relatively flat. You weren't getting a whole lot of droop. So I just cut those out to allow the arms to droop more in case I wanted to do that. And if I need to limit droop, I can do it with shock limiters. Okay, and I could limit the droop that way, or use a smaller rod end or something like that. So there are other ways to limit droop. So this gives me quite a bit more, which is really what I was looking for, and it's comparable to the amount of rear droop that I get. One thing that I would like to do with the front here is to take this bumper and move it in, because there's a whole lot of space here between the leading edge of the front bumper and the front of the front bulkhead or front gearbox. And I talked about this with my Yokomo Works 93, that the setup I had for the Vintage Nationals, I had a bumper that was kind of pushed out a bit. And a lot of the Works and 870C chassis have that, and there are a few bumpers that push closer in to the leading edge of the chassis. And when you do that, you can basically increase the approach angle of the car to a particular jump face. So you can basically take sharper jump faces with a bumper that's pushed closer toward the front of the chassis. So I'd like to do that here, which means I would either have to fabricate my own bumper, which I have the material for it. It would just take a little while, or I can just take this and drill a new set of 4 holes that are moved up by a certain distance to push everything back. The problem there is the distance I would need is larger than the amount of space I have here at the front 2 holes before this bumper starts folding up. So chances are I'm going to have to make a new bumper, which hopefully shouldn't be a big deal. Okay, so the wheel axle or wheel hex part with the universals, this gets a little tricky. So previously I was talking about using the Kyosho Optima re-released universals, which can fit here, and I still have them on here. Those are 62.5 millimeter dog bone length. You can make those work, and I'm going to show you how, but an easier way to do this would be to use Kyosho 65.5 millimeter universals, which are they still use those on their RB6 and their ZX6 and so forth. Those would be easier to get enough dog bone length at full arm droop and still have the dog bone pins contained within the diff out drive. Okay, but what's cool about these older differentials is the way that these diff out drives mount onto the input gears, and this actually gives you some margin for using a shorter dog bone if that's what you have. So what you can essentially do is, because this diff out drive isn't a single piece unit with the input gear, it slots on and then you tighten it down with this little grub screw here. You can put spacers between the inside of this diff out drive and the outer bearing, that goes onto the diff itself, to essentially push that diff out drive out a little bit, so that with a shorter dog bone you can actually have it mate with the diff out drive at full droop. There is a limit to that though, because the actual the output shaft or input shaft that this out drive mounts onto is only so long, and if you go out too far, then the screw that's used to tighten onto that shaft won't be able to actually contact that shaft. So what I did here is I have a wheel axle spacer. You can get that from a few parts. You have Kyosho LA253. This has two spacers. The bronze one is a crush tube, and then this gunmetal colored one is basically a 5mm inner diameter and a 2mm wide spacer. You can get the metal part like this, or on, I forget the actual part number, but on the modern Kyosho kits, one of the parts trees has, plastic parts trees has wheel hexes, and it also has these exact spacers. They're plastic, but for the purposes of what you're trying to do here, it should be just fine. So you take a 2mm axle spacer, okay, and you just shove that in there, and then you mount this diff out drive. It just barely fits. Okay, so that screw, the grub screw that tightens down on that shaft, there's a little portion of it that overlaps the outer edge of that input shaft. So I haven't thread locked any of these yet, but what I might do just to make sure that it stays fixed is to put some blue thread lock on that grub screw and then tighten it down, just to make sure it doesn't come loose, because you don't get full contact area of that grub screw to that shaft. You get most of it, but not quite all of it. And then for the rear dog bone, that's basically all you have to do, and then you don't have to put any spacers on the inside of the wheel axle here, but on the outside of the wheel axle, you use the same kind of 2mm axle shim, and then you put your wheel hex on, and then you're all set. Make sure in this case that you don't tighten the wheel nut down too much, because it will tend to push the drive pin inwards, and that can actually bind with the spacer here. Okay, so there's still margin there to tighten the wheel down and make sure it's nice and snug while also spinning freely. But if you really crank down on it, you can get some bind here. I especially had that problem with the front, and what I ended up doing is not only the same thing with the spacers on the diff out drives, same exact 2mm wheel axle shim or spacer, whatever you want to call it, but also on the inside here of the between the inner bearing and the wheel axle, I put 4 0.3mm shims, so it's a 1.2mm total amount of shimming on the inside here to push the dog bone in a little bit further, because you don't get quite as much clearance between the outside of the diff out drive and the dog bone pins on the front as you do in the rear. So I actually did have to push those in a little bit more. Again, this is with the 62.5mm dog bones, and what that did was allow me to not actually have to use a 2mm axle shim on the outside, because since everything pushes in a little bit, that drive pin gets pushed closer to the outer bearing on the knuckle carrier, but there's just a little bit of a gap there, so I can mount the wheel hex, and I can really crank down on tightening the front wheels without losing any freedom of movement, because there's enough spacing between that drive pin and the outer bearing. They're not going to get pushed together and end up binding. Okay, so that's basically what I did there. And as you can see, I still have to work on the steering rack and the top deck and the electronics mounting and everything, but so far so good. It rolls fairly freely. I mean, it's not too bad. I would say that if I look at my Cat 2000, my Schumacher Cat 2000 cars, or any of my Yokomo cars, they roll about the same distance. Those are belt drive cars. Depending on the belt tension, of course, that'll change how much drag you have in the drivetrain. But they roll about the same distance, maybe a little bit further, with a gentle push. So this is not too bad. Yeah, so obviously more work to do here, and I'll make an updated video when I have more updates. So thanks for watching.